Sorry, take it. All right, so yeah, talking about sediment plumes and what they can tell us about Arctic climate change. Thanks everyone for tuning in today. I've picked quite a specific section of my PhD to talk about with you. If you got any questions about other bits, then feel free to ask, but I'm just going to focus on sediment plumes today. So I've got a quick outline of my talk. I'm going to cover the basic science behind the sediment plume and where they're found, and give you some good examples, some nice pictures, some I've taken and some I've borrowed from NASA. I'm going to say why I'm studying them, what they can tell us about climate change, and then give you a brief insight into my own project. So what is a sediment plume? Well, I looked it up in the dictionary and there was no definition. So I'm going to give you my version of what a sediment plume is. To be honest, it's really dependent on a lot of things, where they're found in the world, like low latitudes, high latitudes. When you find them, like are they occurring all year or like for a very short period of time? The type of water body, so is it in a sea or an ocean? Is it in a river? Is it in a lake? They're all factors that you have to take into account. The kind of definition I've come up for what a sediment plume is when sediment-laden water moves from one system to another. So, for example, a river to the ocean. There's loads of different names. People might say plume, and I might say plume. And by that I mean sediment plume, and I'm using that term to distinguish from a meltwater plume, which is something completely different. So here's a few examples of low latitude sediment plumes. I've got the one on the left is from the River Thames, so you can see a massive change in the colour, from highly concentrated at the coast of east of England, and it kind of moves out sort of in a northeasterly direction towards Denmark. So I thought I'd show one kind of closer to home, and then I've got another which is the Fraser River that runs through Vancouver into the Strait of Georgia. And these are both kind of low latitude, so we live in at about 52, 53 degrees north, and Vancouver's even lower latitude than us. Got some examples of high latitude sediment plumes. So the one on the left is another NASA image showing plumes from the Copper River Delta in Alaska. So we're talking 60 degrees north and above when I refer to high latitude. And I've also got one from Svalbard, which is slightly different in that it's a sediment plume directly from calving glacier front. So a glacier front that discharges ice directly to the ocean. So why study Arctic sediment plumes? Well, the water cycle in the Arctic, I'm using the term turbocharged. It's turbocharged, so that means that everything happens really quickly. You've got a really long winter, dark winter, nothing really happens other than it's cold and snows a bit, and things freeze up, and then your spring's kind of elongated compared with what we have in the UK. And then there's a really short window for things to happen. So all these processes in this figure kind of occur really rapidly in that short period of time in the summer. So talking kind of like middle of June, maybe a bit later, through to the middle of August, and then the first snows kind of come from middle of August onwards, and things start to slow down and shut down for the winter, which is really different to what you'd see in a lowland environment. A lowland river, like in the UK, the Thames, for example, chucks out sediment all the time, throughout the year. It might chuck out more in the after rainfall events, but it's still churning all year. Well, there's climate change, and sediment plumes are a great indicator of how fast the environment is changing. They are a great proxy or analog for glacier melt rates. You can kind of determine how much water is reaching the fjord by the amount of sediment that's in the plume. And also plumes are really important for the marine environment. They, in terms of productivity, it's not my specialty, but fish stocks and like marine plankton and things rely upon the minerals from the sediment that reaches the oceans. So what can I tell us about climate change? I'll show you this GIF quickly, and then I'll turn it off because it's quite horrible, really. Oops. So we can determine the amount of fresh water. Oh, sorry, everyone, struggling here. Reaching fjords and oceans from glaciers and ice caps in the Arctic, which we can use to estimate sea level rise. And I'll talk a little bit more about that in a few minutes when I talk about like using Earth observation data. Sediment plumes are also really important to our marine systems, like globally. So things that occur in the Arctic have influence on other marine processes, ocean circulation around the rest of the world. And finally, like another thing is that you can use plumes to estimate how much a glacier is eroding by kind of calculating the percentage of rock, like bedrock, as you can see in this figure, being ground up by the ice. And this is measured like through the sediment concentration in the plume. And, you know, like potentially warmer temperatures mean more erosion, or I don't know, we might see other processes going on. So moving on to my research, it takes place up in the high Arctic, like about 79 degrees north, so on the archipelago of Svalbard, Spitsbergen. The red star kind of delineates the fjord called Kongsfjorden in Svalbard. So based at the British UK Arctic Research Station, or NERC Arctic Research Station. And there's in a little former mining town called Ny-Ålesund. I've got two field sites that I'm interested in. The first one being this plume here, which comes from a really short river system that takes melt from these two glaciers, Östra and Västra Bröderbreen. And this is an image of the kind of system. You've got really, really red sediment from Östra Bröderbreen, the slightly bigger glacier, and the kind of more milky colored sediment coming from Västra Bröderbreen. And these mix together and then end up in the fjord, coming through a tiny little bedrock channel. And then across the fjord is Blomstrandbreen, which is a marine terminating or a tidewater glacier system. This, as I mentioned previously, this is a glacier that discharges ice directly into the ocean, meets the ice front meets the water, and you can see there's a nice plume in this image as well. So what did I do on my fieldwork last summer? Well, there's a lot of labeling bottles, filling them with sediment, like laden water from the surface of the fjord. And then when I got back in the lab, I'd be filtering them. There's also, this is my supervisor, Jeff. He's got the spectrometer here, and we measure the reflectance of the surface of the kind of murky, turbid water. And this is basically what the sediment. This is basically what the satellites do, but from a very, very different distance. And these three satellites, two being kind of research or government satellites, US government satellites, and then I also am using commercial satellite data from Planet. And these data that I collect with the in situ in the field, like through the spectrometer, can be compared directly with spectrometer data from the satellites. So that's what I move on to now. So for the plans for the future, I'm kind of looking at integrating my satellite, more satellite data into my project. So working from 2000 onwards, which is when MODIS went up into the ether above us and started capturing the Earth on daily. Similar to what Max described earlier on, these 250. This is 250 by 250 pixels or resolution, so it's really, really grainy, and you can barely work out where the land is and where the sea is. On the left, I've got a picture from Landsat, and that's 30 by 30, which is a vast improvement, but they only pass over my study site every 8 to 16 days, dependent on whether there's clouds or not. More recently, Planet have chucked up a bunch of satellites, and they're a commercial company, so I don't have access to all their data because they want money, but they're on a 3 by 3 meter, and they've got multiple satellites taking images of the same locations in a day. So there's so much more data, and the resolution's so much better, so I can calculate the sediment concentrations much more easily. So that's me done. Thanks for listening, and if you've got any questions, then let me know, or we can chat in Discord. Thanks.